So the next thing I'm going to talk to you about is colour constancy. So what is colour constancy first? Does anyone know?
Is it when the colour stays the same even though the light is changing?
Yes, yeah, exactly right. So it is a feature of human vision that ensures that the perceived colour of an object remains constant or relatively constant under varying illumination. And so I'm going to explain colour constancy in relation to the internet phenomenon that was the blue and black or white and gold dress. So by show of hands, who perceives this dress as blue and black? Okay, so slightly over half. Who perceives it as white and gold? So pretty much the rest. Okay, so that's fairly reflective of the population as well. Does anyone perceive it as anything other than those two options?
Maybe a sort of blue and a brown, maybe?
Yeah, so another option is a bluish and a brownish colour, which tends to get categorised into the blue and black camp. So hopefully by the end of this talk you'll be able to understand why this perceptual paradigm occurs across the population. To begin with though, I'll talk about how colour is perceived under shade. This is the simplest variation of colour constancy. And so to highlight this, I'm going to use this diagram here that shows a simple checkerboard with two yellow dots. However, one of the dots is cast into shadow by this green cylinder. And so what can you tell me about the perceived colour of this yellow dot in the shade versus the yellow dot in the light?
The one in the shade is brighter.
Yeah, so that's generally the way that it is perceived by the population, is that the yellow dot that's in the shade appears to be brighter than the yellow dot that's in the light. But if I was to remove everything else from this image, apart from those yellow dots, you can see that they're actually exactly the same colour. Furthermore, what can you tell me about the square in which this yellow dot is viewed? Does the square that the yellow dot's sitting on appear brighter or same or darker than the square of the other yellow dot?
Brighter or lighter?
Yeah, so that's another point, is that the surround of the dot, it also appears brighter. But again, if I remove everything from the image apart from that, we can see that the squares in which they sit are also exactly the same. And so why is this happening? So what's happening here is that we are aware that this cylinder is casting a shadow across the board. And so our brain is telling us that anything that we view in this shadow should actually be brighter than it appears. It appears dark because of the shade. And so our brain is artificially lightening it to the colour that the yellow dot actually is. And because these yellow dots are the same, we perceive this as brighter. It's being artificially inflated in luminance. So moving on now to how coloured light affects our perception. And to do this, I will show you a simple Rubik's Cube viewed under yellow light on the left and blue light on the right. And we can see that the coloured squares on the Rubik's Cube are the same in both cases. For instance, across this front line we can see that we have blue, yellow, red, blue, green, and under the blue light it still remains blue, yellow, red, blue, green. So the colours, we're perceiving the colours of the Rubik's Cube to be the same under both conditions. But I want to draw your attention to two squares in particular, and they are the blue square viewed under yellow light and the yellow square viewed under blue light. And so, to me and to most people, this still remains a blue square and a yellow square. However, if we were to remove the coloured light context from each situation, we can see that the blue and yellow squares are actually both the same colour. And noticeably, they're neither blue nor yellow. So our brain is viewing these and subtracting the blue and yellow light from each case and inferring a colour onto that. So how does this relate to the dress? Well, so there are several lighting cues in this image. What is the first and potentially most obvious lighting cue?
Maybe the background looks really bright.
Yes. So the most obvious thing to me is that the background is clearly overexposed. So if we were to remove that overexposure, then now the background looks a little bit more correctly exposed and the dress looks darker. Has this changed perception for anyone? Does the dress now appear a different colour to what you did before?
It certainly looks more blue and black than it was to me.
Yeah, so this is potentially enough of a change in lighting cues to change people's perception. So now that the dress is less overexposed, potentially you now see it as a blue and black dress, and whereas you used to see it as a white and gold. But what else can you tell me about the lighting cues in this photo? Does anyone know the context under which this photo was taken?
No.
No? So, okay, the photo was taken in a shop front window looking into the store, and the window was displayed in the window, and in the background we can see the store. So the background is illuminated under indoor lighting, and the outdoor, or the shop window, is potentially illuminated under daylight. And so what can you tell me about indoor lighting, a quality of indoor lighting, even in the room that we're in right now?
It's yellowish.
Yes, exactly. So indoor lighting tends to have a yellowish tinge, and daylight tends to have a bluish tinge. And this is related to the spectrum of light that each is viewed under. So daylight tends to be made up of a greater proportion and intensity of bluish light, whereas indoor lighting tends to be a much more yellowish orange quality. And so how does that relate to viewing this dress? So here's a little cartoon to try to explain it. So focus on the right hand side of each image. And so the left image is showing potentially what someone who views the dress under yellow light. So this panel is illuminated in yellow light, and we can see that it looks different to the white lighting of the dress, the blue and black dress. Similarly, this white and gold is viewed under blue light, and we can see how the perception of the colours changes. And what's important here is that the right-hand panel of each dress is exactly the same colour. So if we move that across, we can see that we're perceiving these, what we actually view is the same colour, but potentially our cues are different. So those whose brain is telling them that the dress is illuminated under blue light, subtracting the blue light from the image and viewing the dress as white and gold, whereas those who are potentially, brains are telling them that their dress is illuminated under yellow light, are correcting for that and perceiving the dress as blue and black. So hopefully this has kind of explained to you how these two different perceptual paradigms occur. Is there any questions?